Well, hello. My name is Chris Beckwith. I'm the E10 UPS manufacturer's rep in Western Pennsylvania and West Virginia. What I would like to do to start is do a little bit of UPS 101. What is a UPS? How does it work? And what types are there? A UPS is an uninterruptible power supply. And what it does, it carries the load when the utility fails until either the generator kicks in, the utility comes back on, or you can have an organized shutdown of the equipment that is being backed up. There are three basic ways of accomplishing this inside of a UPS. The first type is what's known as a backup UPS or a standby UPS. It is simply a box like this. It has an inverter and a battery, a small battery charger, and a contactor. Under normal circumstances, the utility is fed straight through the box to the load. When there's a power outage, or if the voltage increases or decreases by a set amount, the inverter kicks on, the contactor opens up, and the battery carries the load for a short period of time, typically in the range of 3 to 5 minutes. When the utility comes back on, the contactor closes, the inverter goes off, the battery starts recharging. That is the most simple UPS, and it really doesn't do anything other than provide a short backup. A line interactive UPS is the next type. It provides more power quality control than a standby. Under normal circumstances, again, it will allow the utility to pass through the UPS directly to the load. It has surge protection, and it has an inverter that can actually act as a buck or a boost to the incoming utility signal. So in addition to power outages and slight overvoltages and undervoltages, it can also do longer term sags and surges because the inverter can actually alter the output waveform and allow it to run while the incoming power is not perfect. Then when the utility goes out, the same thing happens as with the standby UPS. The contactor opens, the inverter takes the full load being supplied by the batteries. And when the power comes back on, the contactor closes, the inverter backs off, and the small rectifier inside will recharge the batteries. The third type of UPS is called online or double conversion. And this type of UPS is completely different from the other two. It takes the incoming power and rectifies it. So between the rectifier and the next stage is the inverter, we've got DC power. At that point is where the batteries are connected, and then the inverter creates a brand new sine wave to the output. So it can handle any kind of power quality issue, from power outages, surges, sags, overvoltages, undervoltages, frequency, any kind of harmonics, and transient surges. So it basically acts as a power conditioner with a battery backup. So you get totally clean power at the output. It's the most popular UPS, and all three-phase UPSs that E10 makes are true online double conversion. So that's for the basics. What is a UPS? Now, why a UPS is the next question people ask. A UPS is used for insurance purposes. It prevents you taking a big loss when something happens with the power. Especially with the double conversion, it takes all the crazy stuff out of the power, like harmonics. If you have a lot of variable speed drives in your facility, they create a lot of harmonics that come back in and can corrupt the clean sine wave. And it can affect certain equipment that is sensitive. Things like variable frequency drives, computers, PLCs, things like that. Industrially, UPSs are applied in many different applications. One is for anything that uses a PLC, CNC machines of all sorts, automatic transfer switches, and VFD controls. When the power goes out, those devices can typically shut down. Anything that's in process on the machines will typically be scrapped. The UPS will prevent that from happening. There are several examples I'd like to discuss where we've used UPSs in industrial applications. The first is a landfill in Western Pennsylvania. They use devices to collect the methane gas that is generated within the landfill, and they sell it back to natural gas companies as green gas. It is worth more in energy credits than standard natural gas, and it's critical that the process does not go down in a case of a power outage. We use the small line interactive UPSs to back up every PLC in the gas side of the landfill. They have generation, so they don't need long run times. They just need it to detect the outage, carry it through for approximately 30 to 60 seconds till the generators spin up and can carry the load again. The second one is a larger application. This one used a 275 kVA UPS, which is room-sized. It was an orbital polisher for a mirror for a space telescope. They were having problems with power quality with transients from local businesses in the area starting to stop large motors, and they were also having trouble with reclosers interrupting power in the middle of the day. They asked us to provide a solution, and we came up with this UPS. They just needed about 30 seconds of runtime. When the power were to go out, they needed to lift the arm of the polisher, allow it to come back and set into a neutral position, and just wait until the power came back on so they could resume polishing. If the orbiter were to stop in the middle of the process, if power just went out, the entire mirror would be ruined. It would have ripples in it and they'd have to scrap it, and it would cost hundreds of thousands of dollars. So the cost of a UPS that was, a large UPS was still way less than even one outage. You've got a critical process where something will be damaged, or you've got molten metals or something in a line, or molten salts or anything, that if the power goes out and it sets in that pipe, you have to replace all that pipe. It should be, first and foremost, put a UPS on it, so that when the power goes out, you can get a signal saying, hey, the power's out, I've only got so much time. You can shut down the process line, allow the pipes to be evacuated so that nothing sets in the pipes. A lot of times people don't even think about that. They're just used to power going out and having the stuff fail and have to replace equipment or having to replace the process material. And it's just the cost of doing business. But if you can avoid that, why not? Why not allow things to run smoothly, not take that hit? Even if it's relatively small, over time they add up and can justify a UPS. What I've discussed here today is just a small sample of what Eaton has to offer in UPS systems. If you have an application, or you think you have an application, please reach out to your ErieTec sales representative and they'll be happy to help you.